depending on the which environment actually, whether they will be under compression or shear, depending on that we have to design. So design also plays a very important role here itself. Now, when you measure the testing properties, there are the three. One is the viscous property which you measure. That means your fluid-like behavior. There is a plastic retention in the IRI, Mooney deformation, rheology, processing behavior, stress relaxation, trick. These are the called viscous property. Whereas elastic property is hardness, elastic modulus, shear, tensile, abrasion. Is a deformation is the instantaneous and reversible. In case of viscous property, deformation is time dependent and irreversible. Once this fluid is gone, viscoelastic property is the combination of the viscous and elastic properties, is the dynamic modulus, heat buildup, resilience. That means that whenever certain energy, that is a dissipation, whenever certain energy you put it itself, dissipation some energy has it. So there is a time, temperature dependent behavior. So this actually, when you're measuring the properties, we have to look into that to have a certain specification to make that how we are maintaining this D by E ratio. When there are the several ingredients, about 10 to 15. I don't want to spend certain time, which you have already know that you select the elastomer. After selection elastomers, you have to considering the vulcanizing or cross-linking agents and then the accelerators. Then comes of the activator retarders, then processing aids, then plasticizers, then fillers, reinforcing, black or non-black, then anti-degradant, antioxidant, antioxidant, protective wax, coloring pigment, the product is color, and the special purpose material, whether it is a blowing agent or deodorant, depending on specific or non-type product. So each ingredient in the compound is a specific function and has an impact on the performance, properties, and the processability, including the price. You can make a very good product of the selectivity, if the price is not competitive, it is very difficult to sell this product. So in order to develop the cost-effective, cost-optimized compound, that means the certain knowledge of the application, knowledge of the function, also the cost of the materials is also well aware by the compound, but should be aware of the compound. Now let me be very clear, there are the different ingredients. Dosage depends on all of you aware of it. That is cross-linking agents, then anti-degradant, then you have there are different doses depending on the pH or what I am giving here itself, depending on the type of the product where and it's going to make the compound for the product. The rubber viscosity reduction, then the addition promoters, the color ingredients, then cost reduction, the extended fillers, and then you polymerize the flame rubber, recycle rubber, cellular structure requires blowing agent, the fire hazard you require the flame retardant, like a phosphorus or antimony salt or borax. Then magnetism, certain rubber products you require magnetic behavior, so magnetic inorganic salt, iron oxide, barium ferrite or barium sulfate. Then high energy radiation, especially high energy absorber like heavy metal salts, lead oxide, especially when you go for radiations, atomic power plant, or electrical insulation, rubber being an insulator, you require, let me be very clear, sometimes non-conductive ingredients, the mineral fillers, hydrocarbon oil, then come the electrical antistatic properties, electrical conductivity, then bacterial resistance, odor. Pharmaceutical application, you have to consider the inert filler, especially the barytas and so on. So I'm telling the tire and non-tire industry, if you have to make the compound for the specific product, the knowledge of each ingredient is required and how much pH is. Similarly, there are the reduction of the surface friction, that is called the heat resistance or low permeability, duplications. So what I'm considering due to the time constraints, you cannot explain. So there about 50,000 or rubber product is there, about let us consider 10 to about 30 different ingredients are required for certain rubber product. So when you select the polymer, you have to consider the cost, because as you know, the natural rubber, SPR, we have the general purpose rubber, depending on the price, certain polymer, natural rubber price has gone on, you go for the SBR, or or beer, depending on the cost of the compounds, what you are looking for. Then comes ease of mixing, what is the physical properties required. Then you require all the properties you mentioned, the TAC is the processing, then service temperature, dynamic properties, permeability. So the polymer selection criteria depend. I will go for subsequent slide how to select the polymer. Then when you select this polymer, then you have to consider the saturation, unsaturation level, polar or non-polar, hydrogen bonding, electronegativity, solubility parameter. The comparability depends on solubility parameter like sulfur, is limited solubility in nitrile rubber, general purpose rubber. Then also require the amorphous and crystalline characteristics, molecular weight or molecular distribution, there's macro and micro properties. Then you require the polymer type and the monomer sequences, the random, alternate, block or graph. So this knowledge is also essential for selecting the polymer. Then we consider what is the unsaturated and saturated. Unsaturated rubber, all you know that if it is they are advantage as well as disadvantage. Advantage is the cost-effective sulfur curing we can select, but they are linked with the oxygen. They are very susceptible to attacks on heat, light, oxygen, ozone. Whereas saturated rubber, they are, there is no ozone or oxygen. Mostly don't require, maximum you don't require any antioxidant and anti-ozonant. So, and second thing is the costly, because you require a peroxide. Cross-linking agent is costlier. But to address that one, we have a main chain saturated and the side chain unsaturated like EPDM, or if you see the halogenated, automatically development is deactivated, unsaturated deactivated. Now these are the different raw materials we are using, all are aware of it. Now out of these raw material, now I am explaining this slide because since this is coming the sustainability factors, as you know that out of this, the compounder should have a knowledge that what is the reactive part, what is the stable part. Generally, when you have a different ingredients, some of the ingredients are reactive, like a silent coupling agent, silica silent, that is adhesives, accelerator, sulfur, stearic acid, retarder, antioxidant, some of the part, and the bonding agent. They really, the reactive material, while mixing, you get a certain fumes and other, etc. This is due to the reaction, maybe H2S, nitrogen dioxide, sulfur dioxide, all these types of the gases are involved. Even some of the low substituent point material, generally they also volatile like anti-PDC. But the stable material is the polymer, the carbon black, mineral oil, resin, wax. If you have to consider environmental friendly, then reactive material you have to see that as minimum is possible. It should not go to the atmosphere, those gases. And stable material is after the rubber product is used, the new legislation, regulation is coming, the tire road wear particles. This rubber, they afraid the smaller particles which is coming, some of the particle 2 to 10 millimicrons is going to the atmosphere, and other is with the underground water. So we have to very, very clear that the stable material, the wear rate and other has to be reduced drastically so the durability should increase. If you see that zinc oxide is another thing matter, people are looking for replacement because this metal is going underground water, which is very not good for the human health. If you look at the structure is considering, so I'm just considering what is the unsaturated rubber. If you see that natural rubber, and this is a polybutane, and hydrogen is going to the methyl, the character changing. So this is again, this one hydrogen replaced with a chlorine, the total double bond is more or less deactivated. But so the question today, the structure, people know that if you know that is it saturated or is unsaturated, easily find out that whether the natural rubber, BR or SBR or nitrile and IIR, all this can be sulfur curable. But depending on the activity, the oxygen, the generally sulfur accelerator doses has to be you have to consider the ratio. Suppose natural rubber, every 5 carbon atom you have a double bond. Whereas in SBR, you have a 23% of styrene, the number of double bond level is less. The sulfur accelerator, if you have a natural rubber, sulfur 2.25 accelerators, let us consider 0.8. Or in case of SBR, it has to be, you have to consider sulfur has to be reduced and accelerator has to be increased to get the speed up to enhance the cure rate. Similarly, the cases of when the compounder must know that what the cross-linking agent will take and what should be the sulfur accelerator ratio. And if you go to the certain mostly main chain unsaturated like EPDN, the EVA, chlorinated polyethylene or sulfonated polyethylene, all these cases main chain mostly the saturated. Now all these require their different curing agents, and they really speaking mostly the peroxide and some cases of the special. And the cure rate also for such type of polymer depends on the type of the unsaturation present mole percentage on the side chain. Similarly, if you see that the other specialty rubber, because especially non-TAD, with the arrival of the electrical vehicles and other, the type of the rubber, auto rubber components will also specialty, more and more specialty rubber will come into the pictures. I will try to explain subsequent slide how to select for which type of the product, which type of the polymer. Now, last but not least is the polymers is the high temperature uses, especially the silicone or the fluorocarbon. All those things really they require the fluorocarbon or silicon. You can go from -100 to +100 degrees centigrade continuous use, no problem. Fluorocarbon up to let us 300 degrees centigrade maximum temperature you can go. So the certain application we require. As as you go for such type of the polymers, the cost of the polymer is going to increase. Now, if you look at how to select, you must have a knowledge how to select the polymer for different application. There is a low temperature, high temperature. So the low temperature is totally the cluster instant temperature is very, very important. And if you look at the service temperature, if you consider that as fluorocarbon is about 300 plus degree you can do. Natural rubber normally 60 to 70 centigrade for continuous use, SBR to about 90 to 100 degrees centigrade and so on. So this table is very important for the low temperature and high temperature and what is the application. Suppose if you want to go for the permeability diffusion, in that case is butyl, halobutyl rubber is very important. So next comes about if you look at this is the slide, this part of the side is the polar and this is the non-polar. Now the polar and non-polar, if you look into the polar rubber which contains the chlorine, oxygen or the nitrogen and fluorine. See this type of the rubber generally they have got the oil resistance very good. But the non-polar rubber is not the oil resistance because most of the oil they are hydrocarbon, they are non-polar, so we require a polar rubber. Now if you see that temperature resistance or the oil resistance depends, the fluorocarbon is the top, that will be very clear, whereas in NR and SBR, they are not the oil resistance at all. So it's very, very important whether you want to make the solvent resistance high temperature or if you want to make an adhesive. In that cases, you require polar to polar, they're compatible, non-polar to non-polar. If you want to do the natural rubber adhesives, then you require since the natural rubber or SBR or they are plain, is non-polar, so you require a non-polar solvent like a gasoline or the mixture of the hydrocarbon oil. Whereas in case of if you go for it's very clear the adhesive based on the synthetic rubber, in such cases you require a polar solvent like acetone, isobutyl ketone and so on. So the compounder must have a knowledge that about the polarity of the polymer as well as the non-polar, including the solubility parameters. So this is the way the selection, then we can say how to select a particular polymer with respect to oil and temperature resistance. If the service is below 100 degrees centigrade, service 100 to 150 degree or service is above 100 degree. If it is 100 degrees, then your NR is beer or oil, then oil resistance. If you consider the natural rubber SBR, there is no oil resistance, there is no ozone resistance, so inner SBR is not suitable for oil resistance, but up to 70 degrees centigrade here. In this range, high cold rubber is difficult to process. This is actually, this gives a little bit oil resistance as well as below 100 degrees centigrade. And whereas service to 100 to 150 degree, you have a nitrile, polypropylene, EPM, EPDM, butyl, epichlorohydrin, and acrylic. You have oil resistance. See that this is mostly the if you consider the EPM, EPDM, IR main shell is completely saturated. These are really non-polar. Automatically, they are very that they are not oil resistant at all. The EPM, EPDM, non-polar to non-polar do not. Similarly, the cases of CR, CSM, and epichlorohydrin, yes, because due to the presence of the chlorine, they are moderate oil resistance, but the inherent ozone resistance. So this chart, the nitrile and acrylic, these are oil resistance very good. High oil resistance 120 degrees centigrade, you can use acrylic 150 degree plus, but nitrile rubber, they do not have ozone resistance. So the compounder must select what you want. If you want 100 to 150 centigrade oil resistance as well as ozone resistance, in that case, acrylic rubber is suitable. But above 150 degrees centigrade, we have a fluorocarbon and silicone. So in that cases, you can see that one. So this table generally, if you see that in case of a silicone also, there are different. One is the methyl vinyl silicone, fluorocarbon methyl silicone, depending on the type of the substitute silicone rubber, the 4-bond RR, depending on the type of the, let us consider whether it is a vinyl group or a methyl group or the phenyl group presence, the property also changes of the silicone rubber. Then the curing system, when you select the base polymers, sulfur, then you have a conventional semi of NAV, or in case of general purpose rubber, you can do peroxide cure as well. So there are the different sulfur curing system, peroxide, resin, metal oxide, radiation. There are different curing systems available that depends on the base polymer, processing condition, curing characteristics, and the service requirement. If we unsaturated rubber, sulfur accelerator, peroxide, resin, natural rubber is sulfur accelerator, EPDM, peroxide, and the butyl halobutyl 5-MP resin. Saturated rubber, completely peroxide, special polymer like a chlorine or halogen containing material, their processing images zinc oxide and magnesium oxide as the acid acceptor. So that means curing system, accelerator activator, if it is a general purpose rubber, sulfur accelerator, then zinc oxide, stearic acid acts as a curing system, or if it is a peroxide, then triallyl cyanuride or peroxide curing system. Now the peroxide condition also, the decomposition temperature of the peroxide is very, very important. If the curing temperature is not sufficient enough to decompose, you get under cure problem. Then service requirement, also curing system, depends on the case of general purpose rubber, if you have a conventional semi, you have an AB, heat resistance, the service temperature, you use natural rubber with this EV system. Duration, this is service requirement, also compounder note, these are the criteria, temperature, duration of exposure, what is the mechanical properties required. The curing system also plays a very important role to enhance certain physical properties, especially the compression set and set property. This already explained to you. Then types of the different types of the accelerator, what is the curing temperature. Sometimes the accelerator, you have a primary and secondary accelerators or synergist you have to consider. The problem for boosting that one, you have a, the slow, medium slow, fast, medium fast, and ultra fast, depending on the curing temperature, whether you use the room temperature or you go for a high temperature curing. Then some of the rheological property, I don't always know that, because when you get the, actually this is called ECG of the rubber compound. That is the reason we have to thorough knowledge those are releasing the compound should have. Generally, the certain things we do the certain thing under cure, certain optimum cure, certain over cure, depending on the type of the properties you require. Suppose below optimum cure time you get a better tear and fatigue or cracking, but the regarding optimal pure gestational property, above optimal pure, generally the set property is much better. There are the different accelerator. Ideal accelerator should be the, you can see that L-shaped curve, maximum score safety, faster curing, and having a plateau. So there are different accelerator range you can select depending on the type of the facility available. So another, this slide, you want to say that this is mostly the compounder, they do not look, especially the residual score safety. Because when you make the compound, you know all these values of the score safety, viscosity, etc. After the processing, the extrusion, calendaring, building, what is the residual safety left is very, very important for the complete flow inside the mold. Sometimes the defect in the molding because the residual safety is not sufficient enough. Sometimes they have to look into the depending on the type of the equipment or temperature generation, the type of the processing equipment you have, and what is the heat history of the compound. So this data is also required to avoid the defective product. Then comes activators. Already I told you that activator may be zinc oxide, or sometimes zinc peroxide, sometimes trialurocyanuride, depending on the type of the polymers. The activators also, the compounder must know, sometimes with the rheometers you have a different graphs, so easily find out which is missing. So this gives you that if it is sulfur, whether it is a weighing error or some accelerators or some booster or some activator is misplaced, the rheometer curve is completely, those who are releasing the compounder to isolate the root causes, the knowledge of the certain standards available should be in the laboratory. Then comes the antioxidants. Why is the antioxidant antidegradant in the compounding? Because if you have the elastomeric property to be maintained throughout the life, the resilience characteristic is very, very important. Because so the resilience characteristic is important. Rubber is coming under dynamic stress as well as the aging. So maybe there will be reversion, cyclizations or revulcanizations occurring. So to do that one, type of the antidegradant antioxidants required, which environment they are going, and what is the ozone concentration they are. Depending on from the manufacturing side, when the tire is going to the product is going to be used, what is the storage life? All this condition was to considering to selecting the type of the anti-degradant, that is whether it will be the exposure to the heat or exposure to the weather or the flexing. That the varieties of antioxidants available, but nowadays I know that certain antioxidant is not environmental friendly. Substitution is also required when you go for a eco-friendly compound. Then you go the reinforcing filler. There may be organic, inorganic. All of you aware of it. I don't want to discuss. But here one must when selecting the filler, the reinforcing filler, the particle size, the structure, the aggregate size, aggregate complexity with the porosity, surface activity, or including the crystallinity is important. That is the reason we have a smaller the particle size, higher the surface area, better is the reinforcement. Same hardness compound with the different type of 100 series, 200 series, 300 series, but you have to adjust the doses accordingly. Then the other non-black fillers, especially non-black products, especially cable insulation, where we cannot use the carbon black, you have to use the inert filler and so on. For the colored product, you have to the titanium dioxide and so on. So if you want to, sometimes the aluminum hydroxide is used for the heat stability of the compound, also used, especially cable and other industry. So then comes about the most important thing is tire industry. The carbon black is a black gold so far using and it is not replaceable, but the way the things are coming, the requirement of the marketplace, the carbon black experimentally partly or fully is going to replace the silica in near future for the tire industry. But one point has to consider when you select the carbon black in the mixing area, the carbon black generally the mechanically introduced in the polymer matrix, the Banbury and other things is the mixture. But when you use the silica, really speaking, there is a chemical reaction of the silica with an activator like silent coupling agent, the Banbury used as a reactor. So in case of a silica silent mixing, one has to know compounder what is the doses of the silent or the ratio, and also mix equivalent, the time to get the proper homogenization or the reaction to be completed, time and temperature is very, very important. That whether it is a 142, 150 or 155 degrees centigrade, what is the mixing room or the time to be getting to see that the salinization reaction is complete. I don't want to explain. Then we have a reason for different processing aid, for the dispersing agent, lubricating, peptizers, homogenizing agent, tackifier, plasticizers, depending on what are the you need, you can select according. I don't want to. Then the resin, that is very clear. Near future, resin is going to very, very, very important role, especially the two contradicting requirement of the tire industry, the durability, rolling resistance, and the traction of the safety, fuel efficiency, and the durable mileage. So the different types of the resin chemistry is coming in near future is big way. Resin comes from the natural resources. For the CI resins, the tackifier, the petroleum resins, generally these are used as you know, something part replacement of the CI resin, the tarpin resin, or the vegetable resin. Depending on the type of the requirement, we can see, but resin always improve the dispersance of the fillers. Now, if you looked into why I'm telling resin chemistry is very important to meet the contact requirement, especially rolling resistance, durability, traction, and noise. Now, the rolling resistance, actually, we new resin, what to do, reduce the hysteresis part. Now, especially the better fuel efficiency, for the EV ranges. That means, if you looked into such a special resins, the performance hydrocarbon resins, or the especially anti-skid weight deep resins, or the functionalized polymer or reactive resin, the bio-based novel vegetable resins, that also synergy with the silica or the coupling agent. So resins plays a very important role for improving the rolling resistance or the traction of weight grip that adjusts the thrust tensile temperature and tire road interaction. The shorter braking distance, then you have a durability wear that improves the filler dispersion. This is the role of resins. And the noise and comfort to modify viscoelastic damping. So the knowledge of resin chemistry is also essential for a compounder. Then also you have to consider how the raw material give the different problem in the compounding. If the rubber is knobby, then dry swell increases. If the high viscosity rubber, poor mold flow. High gritting carbon black, surface appearance, and the lower the tensile stress and property. Low surface area of the carbon black with the poor trade wear. Low surface area of zinc oxide reduce the modulus pore hysteresis. And the poorly ground sulfur is a poor dispersion, poor uniformity, lot of blister, blow time, and so on. Then sulfonamide accelerator, there was storage stability, old storage is a scorching problem because sulfonamide accelerator is a condensation product of the thiazoles and amine. So when you go for a moisture, if the Banbury you have a lot of moisture is coming, so automatically you get a compound gets scorched because sulfonamide accelerator decompose and automatically your cost can reduce and you get the problem in the processing. And then you have a non-uniformity of the wax plan. Wax plan, the carbon chain distribution is very, very important in consistent ozone protection. The high unsaturated in fatty acid, you get a higher hysteresis. In the stearic acid, the high unsaturated is a higher hysteresis. Then high CP residue, you get a flex cracking problem. High acidic phenol resin affected your physical problem. Overexposure of the magnesium oxide, especially polypropylene rubber, lower modulus. So non-uniformity of the clay and etc. you get it, modulus. So that means a compounder must know the raw materials, how it can affect the mixing as well as the processing problem. Then when the compound development, you require the cost and price. Then the new set is a price, processing performance. Then you have to consider set specific objective. What is the property, what is the processing price, then select the best polymer, study the test standard of the existing compound, what is available literature, survey the compound formulation, choose certain starting formulation, then developed in the laboratory, estimate the cost of the compound and specific gravity. There is a not the material cost, the volume cost, then evaluate the processing characteristics in the laboratory, then make a product sample and test against the performance specifications. Then you get a pilot plant trial and industrialization. So the compound development approach choose correct ingredients, viscosity control rubbers, sticking of the compound, mill rollers, and these are the certain steps most of you are aware of it. I don't want to tell you now. This point is the approach is performance, quality, environment. Now the environment is product must be environmental friendly in manufacturing, use, and disposal, because end of the life of the rubber product, end of the life of the tire is already the problem, because as you know the legislation is not to extend the producer responsibility. So whatever product we make tomorrow, you have to take it back, you have to use and recycle and go to your virgin product. In case of a tire compounding, first you have the polymer, filler. Before last point is there is a these things already I explained, but I will now try to give a certain case study. Let me be very clear. This is one important graph we must know, as we know that viscoelastic properties we are measuring mostly their DMA, dynamic mechanical analyzers. When a compound is developing the different characteristics without making simply in the laboratory to know that whether it is meeting your performance requirement. When you do the temperature shift from the minus 100 to plus 100 degrees centigrade, or you can get very clear the V/E ratio, which is called the loss tangent. That is very clear. The aberration characteristics given between the TG area. That means you get the highest value. Then you have a transition zone, because what is actually happening, as you know, reason like this, when the polymer plays a major role, and ultimately the other fillers and etc. But the polymer has got the chain movement, which really is maintaining whether the elastic or viscous behavior. There's the molecular motion of the chain, the main chain and the side chain as well. That means in case of a low temperature, no segmental motion occurs. That means that this is coming nearer the TG. Then we have a limited segmental motion, the low temperature property, that is a transition zone. So the wet traction generally comes between, let us consider 0 to minus, centigrade, and generally the rubbery zone comes, that is when the rolling resistance between the 40 to 70 centigrade, 60 to 70 centigrade, the surface temperature is coming 60 to 70 centigrade. This is the idea. The tangential, this is called the long range of the segmental motion. That means around 60 to 70 centigrade, you know that the V/E ratio is as minimum as possible. The standard value, we get the better rolling resistance. But if higher than about 80 degrees centigrade, you get the hysteresis heat build-up. In that cases, you get a motion of the main chain as well as the side chain. So this graph represents the compound as very good indication about whether we are meeting the properties or not. But what is if you look the future mobility which is coming is called the connected, autonomous, and the shared of the electrical vehicle. Now, the type of the compounding will have changed drastically for certain applications. Let me be very clear. IC and what is the changing? It's called IC engine to hybrid to battery electrical going to the fuel cell. So how the compounding will change. In case of electrical vehicle, we require a thermal management. It should be the lightweight and electrification, noise, vibration, and harshness. Now, in the thermal management, what they mean, because in case of the battery, when you have under the bonnet, the temperature range, generally the plus 10 to plus 15 centigrade, we on the below 10 degree or above 50 degree battery will get discharged. So that is all the hoses which is given under the bonnet to be totally what we are using today. It will be different for the electrical vehicle. And the lightweight is required, as all of you are aware of it, the fuel efficiency or the rolling resistance, etc. If you look that one, the electrical vehicle required most of the auto rubber component, halogen-free flame retardant material, auto rubber components, low smoke emission, self-extinguishing material with the high limited oxygen index, and it should meet with the UL 94 PO regulation standard. That means electrical drive calls for a thermal management, heating and cooling, especially for seals and weather strips, light weighting, mostly the weather strips or the whatever you're making today is more than 1.1 specific gravity should be lighter, but it's the microsolar structure, then there for the noise as well as the safer, higher safety standard is required. Simple example, I'm considering the host solution for EV. Now, generally the EV, what we are considering, because as I told you, the temperature thermal management generally requires EPDM or the epiclohydrin or acrylic or the silicone and fluorocarbon. This is the reinforcing material, so the change will go. Let me be very clear, for inner tube for the hose solution for EV, we require the special EPDM with peroxide cure, and for the ear we require the high modulus, low shrinkage polyester, and the cover we require special EPDM with peroxide cure, and outer cover require silicone or fluorocarbon. So these are the requirements of the host solution for EV, especially the coolant hose. Similarly, the case of the brake hose also it changes. There the tube will be PTFE or the PDM tube. Reinforcement will be we can consider stainless steel, and the cover should be PVC or nylon cover or EPDM cover. So these are the changes will come for the auto rubber components for EV. The EV for the tire is considering you require a ultra low rolling resistance, superior grip, higher load carrying capacity for battery weight, high wear resistance, and resistance to high torque, less noise, better contact pressure distribution, self-sealing ability, and so on. You might have seen the maybe EV tire will be the higher rolling diameter. It will be the if you see that the automatic for low rolling resistance, high rolling diameter will be much better. Now, if you consider the tire industry trends which is coming, actually government regulation just actually, the government regulation is coming for durability, traction, noise, and rolling resistance that we related the safety, environmental. Vehicle manufacturer, they want uniformity, load carrying capacity, low profile, increasing vehicle weight, and the tire manufacturer. So that means this is the trend, and for that trend, these regulations is also compliant. As you write simple, I'm telling you, elimination of the 6 ppg, the tire rubber wear particles, and these are the regulation and stringent tire RRC, the continuous reduction of rolling resistance. So these are the tire trends. That means one side you get a tire leveling, second side new technology, and third is your sustainability or circularity. These are the requirements of the different tires. Basically, if you looked into whether it is a car or the two-wheelers or the OTR or the truck, the requirements are different. Mostly, the one computer must know what is the requirement. Accordingly, the market requirement is the rolling resistance, mileage, retreatability, and the acoustic control, that is NVH. Environmental may require the aromatic oil-free, vehicle gas, greenhouse gas emission, noise, and safety. And other is let us consider the environmental sustainability plays a very important role near future in compounding. Now, let me talk about the how to approach the specialist for such requirement. Suppose if you require a fuel saving tire, that means you require low rolling resistance, improve air retention. Very important. That means this is the pneumatic tire. Suppose with the high inflation pressure, low inflation pressure, your rolling resistance will vary. Even the more durable tire, you require improved retention or your abrasion resistance. So if you environmental reduce raw material, again, durability, abrasion resistance, or lighter tire, less raw material. Improve traction, safer tire. These are the requirements. If you go to that one, how to do that? First is the enhance the interaction between the polymer chains with the silica or the carbon black. The polymer film interaction has to be introduced, reducing the hysteresis property, decrease loading resistance, and build up reduction of fuel. And ultimately, It is that polymer filler interaction plays a very important role to achieve the better fuel efficiency. For that polymer, again, you require three types: on the microstructure related to the traction and wear, or the functionalization, rolling resistance, wear and processability, macrostructure, that is a rolling resistance, there may be molecular rate, molecular distribution, and the functionalizations and the controlling of the TG plays a very important role. Now, see the rolling resistance, a fraction of strain energy loss tangent on the volume. It means in that cases, in case of the materials, you have the silica silent, that is a silica silent toughening agent, that is a bio-friendly material, nano material like a graphene or carbon nanotube, and the functionalized polymer. But the material is considered a compounder, may select there itself. Suppose the structural aerodynamic design, generally designed for weight reduction, sidewall thinning, shape pattern optimization, high diameter, narrow beam. If the maintains a smart, that means automated inflator system, that is a self-inflation technology, smart tap sensor and processing alignment. And EV specific, the high torque compounds, load bearing capacity, low noise cavity. These are the how improvement in rolling resistance reductions. Now, if you look up how will improve the rolling resistance as a compounder, there are a certain guideline. High oil content improves rolling resistance. Low plasticity temperature generally improve rolling resistance. Low filler level improve rolling resistance. Silica silent coupling agent better than carbon black. High structure, low surface area, carbon black improves rolling resistance. Softener that reduces glass tension temperature improves the rolling resistance. Higher cross-link density improves rolling resistance. Silica linker, that is silent coupling agent. Reduction of the free ends of the polymer, that means polymer filler interaction, no extra network material, that means chemically modified high molecular weight. If we say solution SPR, then the vinyl solution SPR is better than the styrene. So the at equal TG. That means these the trans and vinyl ratio is very, very important. These are the certain other, the present terms is that we are doing, say today earlier we are using carbon black, and now, the standard silica and high dispersible silica. High dispersible silica to some extent, actually with the silent coupling agent addressing that one, but the future will be a little bit different. We require a special, advanced composite to see that. I will explain that one. That means rolling resistance, you have to consider the compound chemistry, that is a silica reinforced compound, bio-based resins, nanomaterial like a graphene or functional additive or carbon nanotubes. Traction, trade patterners, the typing, that is the asymmetrical trade. Then in case of durability, material strength, graphene infusions, or the, considering, what is considered self-healing elastomers. Or in case of noise vibration, structure geometry with the internal, the foam or the pitch sequences. These are the certain approaches with respect to component designing to address the trade-off between the rolling resistance, traction, durability, and noise vibration. That means in summary, you require a chemically modified polymer, high structure, surface modified carbon black, synergistic accelerator combination, reinforcing phenolic resins, processing highly dispersible silica and silica silent coupling agent. These are the approach to follow for trade compounding. Now, what is the future direction of the compound will come? There will be very clear, this graph you might have seen in the future. People are trying to get two peaks in the tan delta graph. That means we require, in case of a rolling resistance, is as low as possible, but in case of wet traction peak. So this is also possible by the active adapters or safe memory material, that is the thermoresponsive compound, surface friction, the self-healing, or there is the ionic bonding elastomer instead of the covalent bonding, and the self-inflating system, the nanomaterial and the magic triangle, the graphene infused rubber or silica reinforced, and the sustainability. If you did that, the alternate rubber sources, high sustainable material should be there. This is called the future generation, what they're considering, that is the engineering elastomer composite or advanced composite. That the high TG polymer enhancing the dynamic response of the compound, there is the traction RR trade-off, and the gel polymer having reactive sites which bond to the elastomer. That means this ionic bonding will gain. So these are certain approaches coming for the compounding in futures. Generally, these are the certain guidelines, the trade, sidewall, weld scheme, big filler, inner liner, what type of polymer we select. Second comes about the filler system. Generally, rolling resistance where you require, let us consider highly dispersible silica, about 70 to 90, carbon black, if you consider either 234 or 339 on the structure, 0 to 20 silane coupling agent, 8 to 12%. In case of plasticizer, EDA oil, or the bio-based oil, or the ester plasticizer. These are the certain things about the improvement of this. In case of a pure system, if you look at that the sulfur, CBS, DPG, zinc oxide, stearic acid, what you do, that you have to optimize. That sometimes with the, you can go the typical EV or for the hybrid pure package, the same package is mentioned here, can be followed here as well. But in case of EV tire, let me be very clear, in case of EV tire, sustainable content about 20 to 30% bio content minimum is required. That is the demand of the OEM. Additives may actually antioxidant, TMQ, 6-PPD, maybe 6-PPD is alternative you have to look for. Anti-reversing agents, for the high torque durability because reversing resistance, then processing it, the silica, or dispersion, that is the lower mixing energy. In case of the dispersion of the silica is also available. Noise damping resin is also available for EV. The sidewall and inner liner, the higher catalysts required slightly higher NR and high C gear, especially neodymium catalyst, lower silica, more carbon black, about the 600 or 550 series. Inner liner will be halobutyl, and generally the target should be tan delta about 60 or 70, less than about less than 0.08 or something like the noise optimized mandatory and aberration index. So, and in case of the fuel cell, generally the extra wear margin and ultra low resistance is required. And if you do biofuel, in these cases of ensure resistance to ethanol vapor and higher exhaust temperature, especially non-tire compounds or non-tire now these are the certain formulation I'm considering. The tentative formulation is available in the open literature. If you take the low rolling resistance for the high torque trade, the functionalized solution is BR, solution, normal solution, and high C is BR, neodymium catalyst, then highly dispersible silica, the carbon black, silent coupling agent, bio oil, ester plasticizers, then zinc oxide, stearic acid, sulfur, CBS, DPG, antioxidant GMQ, 6-PPD, and the processing aid. This is one tentative formulation. As what I explained, this can give you certain requirement of what is required for the EV. Now, let me be very clear. These are the certain compounds for the truck tire, generally depending on the whether it is a lug type or the semi-lug or the rib type. Generally, polymer selection depends on that. If you have a rib type tire, generally the natural rubber polybutyl and SPR blends with the neutralized other compounds formulation. But if it is a lug type, then 100% natural rubber wants to take. Then depending on the carbon black and other follows the way we are weighing it. But the selection of polymer followed by other ingredients depending on the physical properties you desire to achieve. In case of sidewall, generally NRBR blend, generally depending on the price up to 50 pHR of NR, 50 pHR, we have no such problem. But beyond 50 pHR of if you go for polybutyrene, the problem of best ratio comes between the 60-40 or let us, depending on the price available, we can go 55-45 and so on. In case of a compound, also natural polybutyrene blend for the resistance and so on, but you have to ensure about the tax. Similarly, when you consider any other compound, first require what is the requirement. Suppose bioactive compound, what is the requirement? The air retention, heat resistance, growth, flex, and space stability and tear. So if you compound select, so these are my requirements, then you have to consider what is the polymer, what type of filler, what type of plasticizer, what activator, antioxidant. Then you go to formulation. You have to say first we have given already the polymer charts and etc. From there you can really calculate what is the polymer required, what type of the filler required. Here in case of tube butyl, suppose you put heat resistant butyl with the low unsaturation EPDM, generally in case of tube higher particle size, normally used to blend of black may be used. Plasticizer high dose of paraffinic oil because butyl is comfortable, not compatible with the paraffinic oil is the best. And activators, antioxidants, and curative. This is the type of formulation. So the component to see what is my requirement, what the major polymers that is available, what is the cross-linking system, and so on. But tomorrow there is very clear sustainable tire material. You require very first of a type of the rubber, natural rubber, the guavili or dandelion. These are going, but the natural will continue. Natural rubber, the most sustainable material. Then the silica from rice husk, then the eco oil, then recycled polyester, then scrap regenerated recycled material, and biomass, the biomass material, and so on. So what is actually happening? We have to consider for sustainable your circular is coming. The material will also be requirement will be different. Already certain people are most of the cases only the rubber chemicals will be the problem. The people are trying the sources of rubber chemical which they are getting from the fruit, whether they can go for the green sources. Already the green aniline, from the green aniline, Lances already developed TMQ from the green aniline. So they are considering it is as a sustainable antioxidant. So when you are using the biomass sources or the biosource,